Hi, this is Ramya Ramasubramanian. I'm a Fall 2012 image processing student. My project aims in the detection of vanishing points on any image such as hallways, corridors, etc. that can be used as an application for navigating the robots. This application can be used for military, hospitals, and other purposes where human life cannot be spared or human labor can be reduced. My project aims at finding the vanishing point of any image. Vanishing point is a point where two parallel lines meet at infinity. Example, if you stand inside in between a railway track, you can you can see that though these lines are parallel, they appear to meet at some point where the tracks are either go turning or it is a dead end or something like that. That is actually called vanishing point, and my project aims in detecting them, especially in hallways and corridors which are constructed generally as parallel structures. This is an example image of a hallway which is dilapidated but still has parallel walls, and you can see that towards the end the hallway seems to meet and there seems to be a dead end. So my project aims at navigating a physical robot in a straight line towards the end of the hallway without being hit by the walls on either side. The algorithm used consists of the following steps. I first read the image, I then blur it, and then find the edges in the image. I filter out and I make the edges stronger, and Hughes transform is used to detect the lines. I find the inliners, outliners, and I detect the point of intersection of inliners, cluster them, and the clustered final point is the vanishing point. This is an example of a hallway image. The given image should be read using an IMRead function in MATLAB. These hallways and corridors are usually lightly lit, so we cannot depend on the lighting conditions, and my algorithm is robust enough to detect the edges of these images even though it is poorly lit. And then I blur the image. Blurring is a process of removing noises in the images, even the bad lighting condition or suppressed because of blurring. I just use a low pass filter to blur the image. This will smooth out the image, and then I find the edges through Canny Edge Detector. Edges or points in the image where the intensity of the pixels change sharply. The boundaries of walls in the corridors are extracted using the Canny Edge Detector. This is a multi-stage algorithm to detect wide range of edges. I then filter the image in order to remove the high frequency and the low frequency components. The low frequency components are enhanced and the high frequency components are removed so that there is a uniformity in whole of the image. Gaussian filter is a filter that I use to remove these noises in the image. This Gaussian filter modifies the input signal by convoluting with the Gaussian function, which is a bell curve function. I then make the edges stronger. My detected Canny Edge detected image is not totally optimal, and it contains both strong and weak edges. It of course contains false edges too, which are actually are not edges. This is done using a STRL function where the shorter lines are removed. I then dilate the image to make the remaining edges appear stronger. I detect the line using Hughes transform. Lines going into the image parallel to the Z axis contribute to vanishing point. Considering our track example, if you stand in between the track, the vanishing point will appear in front of you at a very long distance. This is a feature extraction technique. Hughes peaks are found and the lines are detected. The advantage of this algorithm is that it is so very simple to detect the lines using Hughes transform. The inliners and the outliners are then detected. Inliners are those that contribute to the vanishing point, which are parallel to the z-axis, but the outliners are something which are parallel to x and y axis. Those are simply lines but do not do any contribution to the vanishing points. I have to remove these outliners and then make the inliners stronger in order to detect the vanishing points. Now my all inliners are formed, and then these lines intersect at various points in an image. These points should have to be clustered in order to detect one vanishing points, because if I consider all these points that are formed due to the intersection of inliners as vanishing points, then my output will be perfectly wrong. So I use a k-mean clustering algorithm that clusters every point to the nearest mean so that I finally obtain one single vanishing point. So k-mean algorithm is the process of identifying groups of similar image primitives. This aims at partitioning n observations into k clusters so that each observation belongs to a cluster with the nearest mean. Let me show you some results obtained when I run my code. These are the edges detected using Canny Edge Detector. You can see both the strong and the weak edges here in the picture, wherein after processing this image through the algorithm, the strong edges are made even stronger and weak edges are removed. You can see that the strong edges are made even stronger. So this is the Hugh transform, where the lines in an image is detected, and finally the vanishing point is detected by clustering all the points formed due to the intersection of inliners. This is how the vanishing point is detected. Thank you.